Alright guys, welcome back to Chapter 5. Now in Chapter 5 what we're going to go over is graphing. So we're going to start with graphing reciprocal functions, and then we're going to use some of those characteristics to graph rational functions. And what a rational function is just a fraction that has a polynomial on top and a polynomial on the bottom. And we're going to look at the characteristics of those. So you're going to see a lot of similarities happen here. So in terms of graphing reciprocal functions, consider the equation of y is equal to x. The equation of its reciprocal function is y is equal to 1 over x. Basically what's happening is you take a function, if it doesn't have anything on the bottom of its fraction, you can think of it as being over 1, and you flip it. So like an hourglass, the 1 goes on top and the x goes on the bottom, and that's how we get our reciprocal. So if we're working with these functions over here, y is equal to 7x. If I want the equation of its reciprocal, it would be 1 over 7x. Y is equal to 3x plus 1. Its reciprocal would be y is equal to 1 over 3x plus 1. And last one, y is equal to 9 plus x squared. Its reciprocal will be 1 over 9 plus x squared. And we're going to look at these functions and what characteristics they would have in common, or how they're related to each other in terms of their graphs. And that's what's written down below. So properties of functions and its reciprocals. So the first thing that's related is that if a function has x-intercepts, its reciprocal will have a vertical asymptote at that same x value. So anywhere there's an x-intercept, the reciprocal will have a vertical asymptote at that same x value. Second part that's going to be important to us is positive and negative intervals. So positive intervals means that the graph is above the x-axis. Negative means that it's below the x-axis. So anywhere that our graph is above the x-axis, its reciprocal is also positive above the x-axis. If our function is below the x-axis, meaning it's negative, the reciprocal is also going to be negative. And yet, it just makes sense if we look at the way the equations are. If x is positive, both of those equations are positive. If x is negative, both of those equations are negative. So they share the same sign. Intervals of increase or decrease. So that means if a function is increasing, going up to the right, increasing, then its reciprocal will be decreasing, going the opposite. And same vice versa. If it's decreasing, then the reciprocal will be increasing. And why is that? Well, they're opposites because, once again, if we look at how the equations look, the most basic reciprocal, if x gets really, really big in our function, the y value gets really, really big. But in our reciprocal, if x gets really, really big, well, y gets small because we're dividing 1 by a really big number. And lastly, local maximums and minimums. If a function has a local maximum, the reciprocal will have a local minimum at the same x value. If a function has a local minimum, well, then the reciprocal has a maximum. So they're opposites as well. So you might have some function that looks like this, whatever it is. Its reciprocal, since it has a maximum here, a reciprocal will have a minimum at that spot. We don't know how high or low on the graph. I also see that it has a minimum here, so we'll have a maximum at that spot. So it might look something like this. Nope, not necessarily like that. But maybe something like that. So if we have a maximum, our original function has a minimum. Maximum, original function has a minimum. So, for example, they're opposites of one another, like that one down below. You'll see that when we go through some examples here. So, first things first, we're going to look at our graph of f of x is equal to x minus 3. So x minus 3 is just a linear function that has a y-intercept at minus 3 and an x value, or a slope of 1. So that means it increases like so and goes in that direction. So that's the original graph of f of x is equal to x minus 3. If we want to graph its reciprocal, well, a few things are important to us. We said that anywhere that there's an x-intercept, there should be a vertical asymptote. So I see one at 3, so there's vertical asymptote at 3. Also, a reciprocal will always have a horizontal asymptote at 0. So I've broken this graph into 4 sections. We have 1 up here, 2 here, 3 here, and 4 here. From these ones, we're going to decide where our graph is going to be. So if I take the left side of the graph, it's either going to be up here in 1 or in 2. I know that my graph's going to have to be in 2 because if my function is negative in that interval, meaning it's below the y-axis or x-axis, well then I know that my reciprocal has to be below that axis as well. Whoops. So it would end up looking something like this. Along our horizontal asymptote and down the vertical. And I know that it was never going to be in this section because that's not where our function is. Same goes on the right side. It's either going to be at the top or the bottom in section 3 or 4. I know that it's going to be in 3 because that's where our function is. Nothing's in 4, so I know it's not going to be on the bottom. And based on its horizontal and vertical asymptotes, I know it's going to look something like this. It's going to come down that vertical asymptote and across the horizontal. And that's what our graph looks like. There was nothing down this corner. There's never going to be a graph down there. They share the same part of the graph. We'll continue that for the next one. So another linear equation here. Graph of x plus 2. So if I want to graph x plus 2, it would end up looking something like this. Now when I look at this graph, I see that there's an x-intercept at -2. So that means we're going to have a vertical asymptote at -2. We're going to have a horizontal asymptote at 0. So if I look at this graph and I want to decide which of these sections our graph is going to be in, I see 4 sections. I know that our original function is in 2 and 3, so our reciprocal is also going to be in 2 and 3. So nothing is going to be up in this section here, nothing is going to be down in this section here. So based on our horizontal and vertical asymptotes, I know that the graph has to look something like this from left to right. It's always going to approach that horizontal asymptote to the far left. I also know it's going to approach this one over here. So same idea up in the top corner. I know that it has to come down along that vertical asymptote and across the horizontal asymptote, like so. In terms of that intervals of increase and decrease, you can see that the red line is always decreasing. It's never increasing. So if I take this part over here, our red line is decreasing very slightly, but it is decreasing. Over here it's decreasing a lot faster than it was. And that's because it always works in opposite of the original function. Our original function is increasing here. So our reciprocal is decreasing. Same goes over here. Our original function from left to right is decreasing, still decreasing, ever so slightly over on the right side, but still decreasing. And that's because our original function was increasing from left to right. So they work opposite each other. This one didn't have any local maximum or minimum, so we didn't have to pay attention to that for the linear. We'll see that in the next example. But they're in the same section of the graph, positive and negative sections of the graph, and the increasing and decreasing intervals work opposite of one another. So let's see how that applies to quadratics. We have this quadratic here of x squared minus 4. So if I'm to sketch that quadratic of x squared minus 4, it would end up looking something like a quadratic that has been shifted 4 down. Something like that. And like that. So if I'm trying to graph the reciprocal, which is, we use red, y is equal to x squared minus 4. If I look at that graph, I see that we have vertical x-intercepts at -2 and +2. So that means we must have vertical asymptotes at -2 and +2. We also know that reciprocal functions will always have horizontal asymptotes at 0. So now I've broken this graph into 6 different parts. I have 1, 2, 3, 4, 5, and 6. So my original function is in 1, 4, and 5. So I know that 1, 4, and 5 are going to be where my reciprocal function is going to be as well. So we'll go back and do that. So if it's in 1, it must look something like this based on the horizontal and vertical asymptotes that we have. For 2 over here, a little bit more difficult. One thing that we do know about the quadratic that we have here, it has a minimum at y value of -4. So if our graph of a reciprocal has a maximum at that same point where x is 0, so along this axis we're going to have our maximum, but what number will we have? Well, it'll be the reciprocal of that. So reciprocal of -4 is -1 over 4. So that means that our graph is going to have a maximum, the reciprocal graph, that'll be at 1 over 4, so somewhere right in that region. And based on our vertical asymptote, it's going to end up looking something like this. And finally, we'll finish this graph and we'll come back to that one and we'll talk about it. The last one has to be up in the top right-hand corner because that's where the function is. So based on the horizontal and vertical asymptote, it's got to look something like this. So you might say, how did we end up getting this graph down at the bottom? Well, if we look at the original function of what we're working with, you might see that our graph is decreasing to a point and then increasing after that. So ours has to work, or reciprocal has to work opposite that. And it does, it's increasing up until that point, and then it's decreasing after. It works opposite. It's in the same section of the graph, but the intervals of increase, decrease work opposite one another. So that's how we end up with that. Kind of looks like an upside down quadratic in the middle there. And that's going to happen in a lot of these quadratics, reciprocals of quadratics. And once again, how did we end up getting it to be -1.4? Well, I know that we have a minimum of -4. So reciprocal of -4 is 1 over -4. And that's that point up there for y value. So let's take that idea and we'll apply it to the next one as well. So last one that we have here is another quadratic. If we want to know what the graph is going to look like, well, you just put 1 over x minus 2 squared. That graph of x minus 2 squared, if I was to graph that one, looks like a quadratic that has been shifted 2 spots to the right. So I'm going to put that onto my grid. So that's the original quadratic of x minus 2. This one has only one x-intercept that happens to be at 2, so that means we're going to have a vertical asymptote right there at the 2. We have a horizontal asymptote at 0 for all reciprocals. So in this case, we only have 4 sections. We have 1, 2, 3, and 4. And if I look at this graph, nothing's happening in 2 and 4, so I know those ones aren't going to be used. Our reciprocal is going to be in number 1 and number 3. So if it has to be in number 1 and 3, we only have 2 asymptotes, so I know it's got to look something like this along the horizontal asymptote and up the vertical, this one down vertical and across the horizontal again. So a little bit different than the quadratic that we saw before that went into the negative part of the graph, the bottom half of the graph. This one doesn't, so our reciprocal looks something like that. So that being said, there's some practice questions down here at the bottom, but I'm going to post 4 questions that I want you to try and to answer those, and I'll put the answers up for you as well so that you can follow along. And good luck. We'll talk to you soon.